Hey everyone, welcome to Pre-Cal. We're going to be continuing our discussion of transformations today. And so I wanted to start off with some questions, some reviews, some practice. Our bell work, because it's good to have bell work. What does each transformation due to the reference graph, and how will we carry out that transformations? Two questions today. Part A, we've got 3x plus 1 cubed, and B, 2x squared minus 1, and C, negative f of x minus c. Okay, so take a look at each of these, and in each case I'm going to ask you to tell me what these transformations do to the reference graph and how will you carry out these transformations. We've got 1, 2, 3 different cases here. Why don't you pause the video, give it a try, and come back when you're done or if you have questions. Alright, let me remove this one for a moment. Y equals negative f of x minus c. Okay, so this one, I see this is outside the cubing function and this is inside the cubing function. I know this affects y values because it's outside. I know this affects x values because it's inside, and inside is opposite land. I see multiplying by 3. I do multiplying by 3. So this is a vertical stretch by a factor of 3. And I'm going to carry that out by multiplying the y's by 3. And when I say the y's, I mean the reference point y's. We've got this second transformation here. This affects the x's. Inside is opposite land. So we shift, not right, opposite, left, 1. And to do this, we'll subtract 1 from the x's. Great, so there's the first one. What about this one? Well, I see this is inside the function, so it affects x's. This is outside the function, so it affects y's. Remember, I do what I see. I see a minus 1, I do a minus 1 to the y's. But inside is opposite land. I'm not going to multiply the x's by 2. I'm going to divide the x's by 2. So this is shifts graph down 1. And that's the reference graph. And how will we do that? We will subtract 1 from the y's, and this is a horizontal compression, and we divide the x's by 2. Okay. Now, what about this one here? I don't recognize that as one of my reference functions. No worries, we can still think about the transformations. Negative f of x minus c This is a reflection across the x-axis, and to do it I multiply the y's by -1. This is a shift right C places, and I will add C to the x's. Okie doke. So, there was something else we talked about in the last video that I want to make sure we're comfortable with, and that's what happens when we have two transformations at a time, or two transformations. So, in this situation, it's no problem to say y equals absolute x plus 3 minus 4. We have one x transformation, one y transformation. I can do those simultaneously. I'll just take out my reference points, which I needed to memorize. -1, 1, 0, 0, 1, 1. Inside is opposite land, and I do it to the x's, so I'm going to subtract 3 from all the x's. And this is outside the function. This shifts the graph down 4 places, and to do that I have to subtract 4 from all the y's. And so I get these new ordered pairs, -4, -3, -3, -4, and -2, -3. So my graph looks like this, with -3, -4, with -2, -3. If I plug in a 0 there, I get -1. And then over here we have the point -4, -3. Okay, so that's no problem. There's no difficulty when I have one x transformation and one y transformation. But what happens if my two transformations are either both x transformations or y transformations, like y equals cube root of 2x minus 5. These are both inside of the function, so I know they both affect the x's. Does the order in which I do them matter? What did we say in the last video? As opposed to y equals 2 cube root of x minus 5. Now these are outside of the cube root function, and so I know they affect the y's. What order do I do these two transformations, or does it not matter? So let's start with this one. How do I do this? Pause the video, think about it for a second, look at your notes if you have to, but really you need to have this stuff memorized because it's terribly, terribly, terribly important. Please don't be lazy about this. Okay, welcome back. So with two x transformations, inside is opposite land, we follow SADMEP, which means I have to undo any subtraction or addition before I undo any multiplication or division, which means I'm going to take care of this first and this second. So I'll start with my reference points, -1, -1, 0, 0, 1, 1, and I'll carry out these transformations. First, inside is opposite land, so I add 5 to all the x's. That minus 5 means the reference graph shifts to the right 5. So now I've got 4, -1, 5, 0, 6, 1. We shifted the graph to the right 5 places. Now I come back and I take care of this other x transformation. This is a horizontal compression. I know that because this number is bigger than 1. And to do that, we don't multiply all the x's by 2. we're doing inside is opposite land. I see multiplication, so I need to divide all the x's by 2. And so my final points are 2, -1, 5/2, 0, 3, 1. So let's think about our graph here. It looks like square root over there and negative square root over here. And this should be vertical here at that inflection point, that middle point. So we've got 3, 1. We've got 5/2, 0. And down here we have 2, -1. Okay, so when we're carrying out 2x transformations, SADMAP tells us the order in which to do those transformations. Now, is that true for these 2 y transformations? Why don't you pause the video and think about that for a moment, and come back and check your answer when you're ready. Okay, well, with 2 y transformations, PEMDAS is what I follow. Outside is normal land. I do what I see. I follow the traditional rule of PEMDAS. So I know that first, I'm going to multiply all the y's by 2, and then, because the m comes before the s, then second, I'm going to subtract 5 from all the y's. I'm still going to start off with my reference points, -1, -1, 0, 0, 1, 1, and now I'm going to multiply all the y's by 2, boink, 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 which is -1, -2, 0, 0, 1, 2. And now I have to come back and do the second transformation. I have to subtract 5 from all the y values. And so I end up with the points -1, -7, 0, -5, and 1, -3. So here's our -1, -7. Here's our 0, -5. Here's our 1, -3. And there's our graph. So remember, when you have 2 y transformations, you follow PEMDAS. And if you have 2 x transformations, you follow SADMAP. So let's practice doing some of these transformations of reference graphs. Let's start with this one. Y equals 4 square root x minus 1 plus 3. All right, why don't you pause the video, use your transformations on the reference points, graph it, don't forget to label the points on the graph, and come back when you're ready to check. Okay, so I know that when I start this, I have to start with the reference points, 0, 0, 1, 1, 4, 2. And remember, we said a few videos ago, these reference graphs, you have to have them memorized cold. You have to know their shapes and their reference points, because look, we can't do this transformation stuff without knowing it. All right, what do I see? I see 2 y transformations, and I see 1 x transformation. I know inside is opposite land, so I see -1, which means I do +1. Now I've got these 2 y transformations, and we just got through saying when you have 2 y transformations, you follow PEMDAS, and PEMDAS says multiplying comes before adding. So we're going to multiply all the y's by 4. And I'm going to have 1, 0, 2, 4, 5, 8. But we still have this second y transformation to do. That shifts the graph up 4 places. This stretched it by a factor of 4 vertically. Now we're pushing the whole graph up. We're going to do +3, +3, +3 to all the y values. So what will our final points be that we need to graph? 1, 3, 2, 7, 5, 11. Remember, this is a square root graph. Think about the curve. It's got a starting point with its restricted domain, and then it goes forever. So I'm going to just draw that and label 1, 3 over here, 2, 7, and 5, 11. And there's my graph. If you want to anchor it on axes, that's fine with me. But I don't recommend, at the very least, doing this. Please don't do this. It's a waste of your time. It's terribly inaccurate. It ends up confusing you, even though you think it's helping you, because you don't get the smooth curve. You start drawing linear equations. All right, how about this one? Y equals negative square root 2x plus 4. Why don't you try graphing this one? The reference points will still be the same, 0, 0, 1, 1, and 4, 2. Think about what these transformations do to the reference graph, and think about how you carry out the transformations. Why don't you give it a try and pause the video, come back when you're ready to check, or if you're not sure and have some questions. So, I see only one x transformation again. Inside is opposite land, so I know I divide all the x's by 2. I see two y transformations, this one and this one. This is not subtracting, it's negative 1 times that square root. So I have to multiply negative 1 times all these y values. Why am I doing times negative 1 before plus 4? Because PEMDAS says I need to do the multiplying before I do the adding and subtracting. We get 0, 0. We get 1/2, 1, negative 1, 1/2, negative 1, and we get 2, negative 2. But we still need to come back and do the second y transformation, and that means adding 4 to all our y values. So my new points would be 0, 4, 1/2, 3, 2, 2. Now, one thing to watch out for is I see a lot of students do this beautifully, and then they draw this. And they say, okay, that's 0, 4, that's 1/2, 3, that's 2, 2. What's wrong with that? Take a look at it and tell me what's wrong with that. Look at the y values. This y value of 4, should it be lower than this y value of 3? And should that y value be lower than this y value? No, this isn't our graph. This is a common mistake. Watch out for it. Remember, this transformation here flipped the graph upside down. We multiplied all our y values by negative 1. So our graph actually goes like that. 0, 4, 1/2, 3, 2, 2. Okay? You really need to be thinking about these transformations and not just sort of blindly doing stuff, right? I need you to think. Think about what's going on. Think about how to carry out the transformations. Think about what the transformations do to the graph. Okay, let's try some more. How about y equals 2, 3x plus 5 to the third minus 1. Okay, so what do you see? I see a bunch of transformations. How do I carry them out? Remember, does the order matter when I have two y transformations or when I have two x transformations? Why don't you give this one a try and pause the video and come back when you're ready. Okay, I'm going to start off with the reference points. And now I'm going to apply my transformations. I have two y transformations, and I have to apply those using SADMAP No, that's X transformations. I need PEMDAS. I need to take care of any multiplying before I take care of any subtracting. So I'm going to multiply all the y's by 2. Meanwhile, I see here 2x transformations. I know inside is opposite land, and here's where I use SADMET. And so I need to take care of this addition before I take care of this multiplication. Inside is opposite land, so when I see plus 5, I have to do minus 5. That will bring me to negative 6, negative 2, negative 5, 0, negative 4, 2. We still have 2 more transformations to do. I still have to subtract 1 from all the y values. And I need to divide all the x's by 3. So my final points then will be negative 2, negative 3, negative 5 thirds, negative 1, negative 4 thirds, 1. Now, you could certainly make a scale where you said, okay, these are all thirds. Negative 1 third, negative 2 thirds, negative 3 thirds, negative 4 thirds, negative 5 thirds, negative 6 thirds, which is negative 2. So I've got that point, negative 2, negative 3. I've got this point here, negative 5 thirds, negative 1. And at negative 4 thirds, we have this point here at 1. And remember, you need to draw in the characteristic shape for y equals x to the third, which looks like an up-pointing parabola there and a down-pointing parabola there. I don't like using this kind of scale because the distance here is definitely not the same as the distance here, and so that's going to affect the way I look at the graph. Instead, I'd be more likely to say, okay, I didn't reflect this, I don't see any minuses, so I know I just have my regular x to the third graph, and I just label my points, negative 2, negative 3, negative 5 thirds, negative 1, and negative 4 thirds, 1. And if you really want to have axes, great, draw it in. Between negative 1 and positive 1, I'm going to have an axis. And then somewhere over here, I have my y-axis. Okay, let's do 1 or 2 more of these, and then let's switch to our last topic of the video, going backwards. All right, so how about this one? Y equals negative, there we go, 4 minus x over 2 cubed minus 3. Okay, give it a try. Come back when you're done. So, welcome back. I just want to say sometimes it helps students to rewrite something like this way. This is called the commutative property of addition. A plus B is the same as B plus A. And if I'm stuck with this form, I can always flip these to make this form. So be mindful of that opportunity. I'm starting with the reference points, negative 1, negative 1, 0, 0, 1, 1. And I'm going to apply my 1y transformation. That's going to shift the graph down 3, so I have to subtract 3 from all the y's. I've got 2 x transformations here that I need to take care of. Remember, inside is opposite land, so we don't follow PEMDAS, we follow SADMET, which means I need to take care of any subtraction and addition before I take care of any multiplication or division. So that means I need to do this first. I need to subtract 4 from all the x's. I'll have negative 5, negative 4, of negative 4, negative 3, of negative 3, negative 2. And remember, these are the same reference points as like y equals x. So, you could pass through all these points on a line. It's not sufficient just to do the transformations. You have to be thinking about the reference graph. This is y equals x to the third. All right, so we're almost done with transformations. And what do we have here? Well, instead of dividing the x's by negative 2, I'm going to do the opposite. I'm going to multiply the x's by negative 2. Multiply by negative 2. Multiply by negative 2. And so we end up with 10, negative 4, 8, negative 3, 6, negative 2. So over here at 10, I'm at negative 4. At 8, I'm at negative 3. And at 6, I'm at negative 2. And this is x to the third. But this reflected my x to the third across the y-axis. So my graph looks like that. Don't forget to label the points on the graph: 6, negative 2, 4, negative 3, and, 8, negative 3, and 10, negative 4. Okey-doke. Great. So, you'll have more practice with this in tonight's homework. I promise. Tonight's homework is a bunch of stuff in the textbook, so you'll need to get the scanned pages from that from our Office 365 team. But I want to start doing some going backwards problems. And we'll work on this a lot more in the next video. So in this situation, we're going to be given, I don't like that, we're going to be given a graph like this one. This point is negative 4, negative 1. This point is negative 3, positive 1. And this point is negative 5, negative 3. And we're going to be asked to write the equation for this. Okay, so let's have a little recipe for that. 1. Determine which family of curves. In other words, we're saying, what reference graph are we talking about? Well, with this shape, it's not a parabola. It's not absolute value of x. This is y equals x to the third. So the second thing I'm going to do is I'm going to use a general form. And by general form, I mean something like this. A, b, x minus c cubed plus d, where I have all 4 transformations. Okay? In fact, let's make it easy on us. Today, we won't have any of these. So, this goes really easily once we use the appropriate general form. Now, if we had thought this was a square root, then I would have y equals a square root x minus c plus d. And if we had thought this was absolute value, I'd have y equals a absolute x minus c plus d. And if we had thought this was cube root, y equals a cube root x minus c plus d. So I'm going to use that same format, that same pattern, once I identify which family of curves I'm looking at. Now, how do I find the letters? Okay, well, that's easy, actually. On the reference graph, this point is 0, 0. And so, what did I have to do to this to get this? Well, I had to subtract 4 from all the x's. And what did I have to do to this to get that? I had to shift the graph down 1. I had to subtract 1 from all the y's. And so very quickly, I can come up with a x minus a negative 4 cubed, and then we shift it down 1 minus 1. Our c value is this number. Our d value is this number when we use the 0 point. Finding the 0 point, and by the way, all our reference graphs have the 0 point. Finding what happens to the 0 point allows me to claim a c value and a d value and just plug them in. So now I'm looking at x plus 4 to the third minus 1. All I have to do now is find this a value. And so 3, plug in the 0 point for c and d. Finally, step 4, plug in another given ordered pair for x and y to solve for a. Okay, I've kind of run out of room here, so I'm going to erase a little bit up here. Okay, so I'm saying pick one of these other ordered pairs, like negative 3, 1, and plug them in for x and y. So we have got 1 equals a negative 3 plus 4 cubed minus 1. Now let's solve this equation for a. I add 1 to both sides, and that gives me 2 equals a negative 3 plus 4 cubed. Now what is negative 3 plus 4? Well, negative 3 plus 4 is 1. So now we've got 2 equals a 1 to the third. And 1 to the third, well, that's just 1. 1 times a is a equals 2. And so then my equation for this graph is y equals 2, x plus 4 to the third minus 1. So that was our 0 point. We shifted the graph left 4 and down 1. So this says left 4 and down 1. And then we used another ordered pair to find our a value. And that's all we had to do. So let's do a couple more of these, and then you can get to your homework. How about this one? What family of curves does this belong to? Negative 4, 5, negative 3, 3, and negative 5, 3. Okay. What do you think? What family of curves is this? Is this absolute value? Is this a linear function? Is this cube root? No, it's a parabola. So let's start off with y equals a x minus c squared plus d. Why don't you go and pause the video and see if you can use the given information to write the equation. Come back when you're stuck or done to compare your answer. Okay, so the first thing I need to do after I've determined this general form is find the 0 point. This point, this middle point on the reference graph, negative 1, 1, 0, 0, 1, 1. There's my 0 point, my vertex. The vertex is always the 0 point. So here's my 0 point. And what do I need to do? Well, I need to plug that in for c and that in for d. So I'm going to have y equals a, x minus a minus 4 squared plus 5. I like tidying this up, so I'm going to write that as plus 4. And now it makes sense to me. I shifted the graph left 4 and up 5. I went from here, left 4. I went from here, up 5. Now what do we need to do? That's right, we need to find that a value. And we find that a value by plugging in one of these ordered pairs. 3 equals a, negative 5 plus 4 squared plus 5. Negative 5 plus 4 is negative 1. Negative 1 squared is 1. 1 times a is a. So I have 3a plus 5, or negative 2 equals a. Negative 2 equals a. So now I can write my equation for this downturned parabola. Y equals negative 2, x plus 4 squared plus 5. That negative is really important because that's what gives me the downturned parabola. Okay, let's see if you can do this one on your own. Here's my graph. This point here is 4, 3. This point here is 5, 5. This point here is 8, 7. So, think about what family of curves, write down its general form, apply the 0 point, and then use a second point to help you solve for it. Pause the video, give it a try, come back when you're ready to check. So, I know this is part of the square root family. So we're going to start with this. Where's my 0 point? It's not that one. Remember, our reference graph has a 0 point, but it's the end point. This is my 0 point. I go right 4 and up 3. So, minus 4, up 3. Right? Doesn't this minus 4 mean I shift to the right 4? I'd be adding 4 to all the x's to get me from 0 up to 4. And then to find a, I'm going to plug in another one of these ordered pairs. Let's use 5, 5, or better yet, 8, 7. 8, 7, 8, 7. Sure, 8, 7. 7 equals a square root 8 minus 4 plus 3. So now, I've got 7 equals a square root of 4 plus 3. Square root of 4 is what? Square root of 4 is 2. 7 equals 2a plus 3. Now, I want to caution you. I see a lot of students doing this, and then you know what they do? They turn it into 5a. No, 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 no. Tears of a small child. No, they're not like terms. You can't combine them. Don't do that. Oh my God. Okay, so instead, I'm going to subtract 3 and get 4 equals 2a. I'm going to divide by 2 to get a equals 2. So, a equals 2. There's my equation. Let's do one last one. Our last one looks like this. Ugh. Really should always just draw it from the inflection point, because that needs to be flat there. Okay, we've got some points. Negative 4, 5. Negative 3, 2. And up here, negative 5, 8. Alrighty. Please write the equation for this polynomial function. Alright, welcome back. We know this is y equals a x minus c to the third plus d. Where's my 0 point? Well, on the x to the third graph, the 0 point is the middle point. So I'm going to look to that middle point for my c and d values. There it is. So now I'm going to have y equals ax minus a negative 4, and then we shifted up 5. Oops. Up 5. Now we need to find our a value by using one of these other points. How about negative 5, 8? So I'm going to plug in 8 over here. A, negative 5 plus 4 cubed plus 5. So here, negative 5 plus 4 is negative 1. Negative 1 times negative 1 times negative 1. This is negative 1 cubed. Think about negative 1 cubed. It's not negative 1 squared. It's not going to be positive. Negative 1 times negative 1 times negative 1 is going to give me negative 1a. So I have negative a plus 5. So in order to solve this equation for a, I need to subtract 5. 3 equals negative a. We don't want negative a though, we want positive a. So I have to divide both sides by negative 1. So a equals negative 3. So my equation then here will simply be y equals negative 3 x plus 4 cubed plus 5. Okie doke. Well, we'll have more practice with this in our next video. Don't forget to send me questions in GroupMe or email me if you have to. Your questions, attend the Zooms that we set up to ask questions there as well. We will be assessing on all this material. You do need to know this. Your grade does depend on it this semester. So make good use of your time and really work to own this material. Not just to do the homework, but to actually own what you're doing. The homework is not a punishment. The homework is an opportunity for you to help get this in your head. It's not to rush through it and forget everything the next day. It's to learn it, and then with the homework, deeply learn it by your practice. Okay, take care, everyone.